Yeah, so guys, it's afternoon, right? It's the last day. Seriously, I was very excited to be here, back in PyCon. Everyone, so much people, right? Everyone is working on Python. Yeah, I'm working on Python. So, you learn something new every time when I come to PyCon. We can go back and experiment, come back next year, meet new people. That's happening for some time, yeah. Yeah, and so today we are here to present IndicNLP. So we have been working on this for an year now. I'll start with the story. Everyone has been asking me how we started this. Why did you go with IndicNLP? What was the motivation and everything? But it's a funny story actually. Um, so first, I'll introduce my teammates. I'm Adam Shamsudeen. Um, this is Selva Kumar. This is Kamal Raj, and we also have Soham. Currently, he's not with us because he's in Singapore doing his masters. So Soham worked on Bangla, and I and Kamal worked on Malayalam, and Selva worked on Tamil. So yeah, let's go forward. Uh, s- yeah, yeah. Everyone has this dilemma, right? Should we do it or not? Right? That's the whole how this began. I work in Sama Technologies. All of us actually, when we started, we work. I was working on a project called Dahlia. It's a chatbot platform. So we were using all the latest NLP techniques, transfer learning, ULM fit, DPCN, and different architectures, right? So I was thinking, why can't we do the same thing in our own languages? Because there are a lot of things out there, a lot of research papers, a lot of data sets, but why isn't anything in our mother tongues, maybe Tamil or Malayalam or Hindi? There isn't much, right? So what I did is I went through a couple of the papers, like where can we get a data set. That's when I saw a paper from Salesforce. It's from Stephen Merity, and I don't know the author. So I thought maybe I'll tweet at him and how he got the data set. How can I do the same thing? So back in August last year, I was just thinking I'll just tweet at him. Then I thought, should I do this? I mean, everyone thinks that way, right? Should I send him? And he's like a big guy. Should I send him one tweet? Will he respond? What will everyone think? And I thought, okay, let's do this. So I sent him a tweet, and he responds back. He said, yeah, we have script for that, right? Just send me an email or a message. I'll send you this thing. So, yeah, and so we wanted to do ULM fit. So that's when ULM fit came out. So in ULM fit, what we were excited because it was transfer learning. There was never transfer learning in text, so we wanted to do it for Malayalam because we don't have enough data, right? So I also tweeted at Sebastian Ruder and Jeremy Holtz. So Sebastian Ruder, if you're into NLP, like he's like really good in NLP. Um, so I tweeted at him, and he also responded. So that's like a boost. These guys are really big into NLP, and they're ready to help anyone, anywhere in the world. If you have just a Twitter, right? Just tweet at them. They'll be happy to respond. So what we did is um, we got the data because there was some helper these things. So we went on, we downloaded it, we got the data, right? Um, so what next? That's when the story of banana cake comes in. Okay, so it's a funny story again. Uh, I got the data set. I don't know what to do because I know NLP, but our team has a very good NLP people like Selva and Kamal. So I asked Kamal, man, can we do ULF fit on this? Are you interested? He's like, yeah, we'll do it next week, man. We'll do it next week. Maybe if you buy me a banana cake, I'll do it today, right? He was like, okay, I'll do it today if you buy me a banana cake. So I got really okay. Then I went out. I just bought a banana cake. He had like two slices. He started coding, and I told him like if you are done with when you finish it, you can have the whole cake, right? So he got excited, and he got excited because of the cake, and he started doing it, and we were really excited that we got a very good perplexity on the language model that we trained. Um, and we were like thinking, what should we do next? We have a language model, that language model predicts the next word, what should we do next. So that when we realized there isn't any data sets for any task in Malayalam. So we went on to a website, a popular Malayalam website, and we downloaded some newspaper articles, and we categorized them to 5, like sports, business, entertainment, and we did a text classification on top of that, and we got a very good accuracy of 92%. And that's when we realized we can actually apply a lot of deep learning techniques in our languages. So when we were done with that, I told Selva that we got a good thing. So he's like, "Oh, you guys did it. I also wanted it to do it for Tamil." So he got excited, and he did something for Tamil. And then Soham joined. He did something for Bangla. So that's how it all started, right? So when we went in deep, we realized that there isn't much, right? No data sets in Malayalam, Tamil, or English that is publicly available. And even if there is, these are with academia, like universities in India, and they are not willing to give any data sets to outsiders. You might be seeing a lot of research publications in IEEE saying that they got a good accuracy on this data set using this model. They have a good classifier, right? But none of these things are publicly available. So people like us can't actually work on it, improve it, and bring maybe new models, right? New models. So, and even one day we found a NER data set publicly available, and we were so excited, right? I don't know the name, it was Fire, I guess. And we downloaded, and we realized that it's a zip file, but it is password protected. And they're not willing to share the password with us. So these are the issues that we went through. Next, I will call Selva, and he'll explain why language is hard and why we need an open data platform.
Okay, I am Selva. So 2 things, why open data and why language. I have a 14-year-old friend who develops Android applications, and I have a 40-year-old friend who does data science. I used Arduino to create robots, and people use Raspberry Pi, BeagleBone to create drones. And there is entire hardware movements to create mesh network, like an alternative internet. So these are all possible due to many factors, but one of the primary thing is free software movement. Having access to code and how the software works. So the softwares we use, Vim, Emacs, Linux, Firefox, and of course Python. They are very famous and stood the test of time. And they all have something in common with a bicycle. They are easier to modify. You can disassemble and reassemble a bicycle in a matter of half a day or a day. And why does it matter? So one of the things with free software is it's easily customized. It can be tailored to run from smartwatches to supercomputers. And how did this happen? Where there are tech-savvy people like Linus Torvalds and Stallman who have worked on harder code bases, but also community effort from common population. So if communities have access to the inner workings of the things they use, civilizations move forward. But there is a problem coming up because softwares are changing in a sense that the inner workings of the software is not just code anymore. The code doesn't give you a full picture of what the software does, because the ML and the AI train they are learning. They are just hand coded. They are learning from data, and even if you have access to the entire code base, without access to the data that they learned from, it's very hard to modify to suit our needs. That's why open data is very essential for another revolution that happened in free software to happen in machine learning or AI. So another thing, why language? Yeah, I'll come to the later. Okay. So people thought solving chess, checkers, Go will lead to AI because intelligence was thought to be rational and calculating. But we have solved chess, Go, and checkers almost completely, but we still don't what we meant by AI. So the definition of intelligence is a little different and it's evolving. One of the definitions that, as a guy who works in NLP, I have is if a system understands language, I can safely say that it is pretty smart, at least smarter than a monkey. So, why language? Everybody speaks language. How hard could it be? Let's see. In French medieval times, they had a game. There is a pot you pull your money in, and if you hit a chicken with a stone, you get all the money. This is where the term pool comes from because chicken in French is poultry, pole. That's where the memory pool, thread pool we all use, right? So another thing, why cat refers to an animal, and why does it refers to an animal that meows and not the dog that barks? What is in that C, A, and T in that order makes up a cat? Are the meaning of words entirely composed from individual letters, or the relationship is arbitrary? This is at word level, right? When you go to sentence, so what do you think? This is, let's talk about rights and lefts. You're right, so I left. But if you read it, there are too many words: stock, outright, sand, our, right, and soil. Chunking sentences into word pieces is a very hard thing to do. For us, it's easier, but when you just feed in to a tokenizer, just goes crazy. Another thing is how words follow order and create meaning out of individual words. How are you is a meaningful sentence, but are how you is not in English, of course. And that is the order of words, the syntax, how it matters. This thing, the green marble went to sleep furiously last year. It's a valid English sentence in terms of noun and verb order, but it doesn't make any sense, right? This is a semantic problem because we need knowledge of the world we live in to understand the meaning of sentence, and the sentence to be valid, it has to follow some worldly laws like physical laws. Another thing, so when your wife yells, look at the mosquitoes. If she does not admire the mosquitoes, she is telling the windows are open and asking you to shut it. So that's why language is a very hard problem, and if a system understands language, we can impart knowledge onto it just by talking. And we hope to do we all hope to do so in at least next 50 years. So I'll now hand over to Kamal, who will talk about the technical aspects of the talk.
So, as an IndicNLP platform, I will explain what have we done so far. So, we collected our data from the initial data collected from our Wikipedia. This is a dumb, unstructured text. That's where we created our language model with around perplexity of 36. So then again, like after developing a language model, we didn't know how to evaluate the language model. We need further downstream tasks to evaluate the performance of the language model. So we collected data from news articles under like different category, entertainment, sports, business, etc. So that's where we collect data for our supervised classification model in Tamil and English, Malayalam. So as a first our deep learning approach, we created a word-to-vec model. We actually use the open source tool called Gensum. So we have created word-to-vec model for Malayalam, Bangla, and Tamil. See, we already open source this course and model, and we also have a UI on top of it. Then after that, we also try transfer learning in NLP. So we use an ULM feed. So currently we are working on BERT. So first task of most NLP problem is how to represent text in a machine understand. So initially there were like statistical models like bag of words, where we just represent a count of words. We just take the count of words. So the words doesn't have any meaning. So like we are representing the words using the continuous vector space, where semantically similar words are mapped to proximity points in the geometrical space. So what we can do is we can click on a word, then we can get all the similar words associated to it. So the word level meaning is very important when we are coming to the NLP problems. And also when we so we have two models. One is continuous bag of model and a skipgram model. So what a continuous bag of model does is, so it takes an input as a one current word, so it tries to predict the context of its words. That's the first second model. So the skipgram model is exactly opposite to the continuous bag of words model. So it takes the current word and like its output the all other words, context words. So we train the skipgram model for the Malayalam and Tamil language. So as we don't have a lot of data, skipgram model works with less data. So and like for evaluating the this is unsupervised model. For evaluating also we don't have any data set. So what we actually did is we have a TensorFlow embedding projector. So we projected our word representation using that. Then we manually analyzed the word clusters. So where we found like how we tuned the hyperparameters and like we manually created our the size of our vocabulary. So most of our like word to vocabulary is around 10,000. So then we, after creating the word to vec model, we try the normal LSTM classifiers. Okay, I will show you a demo of how word to vec works. So this is for Bangla. So we are clicking on the word called okay, Tamil, there is a word called rat. So when we click on the word rabbit, we get all the animals like rat and cheetah and everything. In Malayalam, we are clicking on the word called January. When we are clicking on the word called January, we are getting all the months related to the January, that is November, December and everything. Okay, so after creating the word to vec model, what we did is we created normal LSTM based classifier. So like as a first layer, we use the pre-trained embedding that we already created using the GenSum model. On the second layer, we have created the LSTM, bidirectional LSTM. So bidirectional LSTM is used to capture the word meanings from the both direction. As like in a sentence, the word can have dependencies in both direction. Then the final output from the LSTM layer is taken into a fully connected dense layer, followed by a softmax activation. So in this configuration, we got around 89% accuracy on our news classification dataset without any like fine tuning like for the hyperparameter search or anything. It took around 1 hour for training. So after doing that, we are excited to do transfer learning in NLP. So transfer learning is an approach where like you apply we train a large model on a huge amount of data. Then we use that domain knowledge to transfer the knowledge to a simple task where we don't need a huge amount of data. So the transfer learning is very common in computer vision. So this is the first paper in transfer learning on text. This model is called ULM fit. This is the implementation of fast AI. So what are we doing in like ULM fit is, first we train a language model. That's the first figure. So what happens in language model training is we will input a two or three words, then we will try to predict the next word. That's how the language model is learned. So it actually learns the semantic and like relationship between the birds and all other things. So what do we do in the second step is we will fine tune the language model on our preferred dataset. Here the first language model is trained on the Wikipedia, and second language model is fine tuned on our news classification dataset. Finally, on the third classifier fine tuning, we remove the final language model layer and add an softmax layer as in the LSTM classifier to classify on the newsers. Here we actually with around 10k samples, we got around 95% accuracy. Then currently we are working on like BERT for Indic languages. So BERT is a like little different architecture compared to all the all the other transfer learning models. BERT is on like works on transformer model. This transformer model is from Attention is All You Need paper by Google. So there's a little different from all other language models. This is a mask language model where we predict instead of the next word, we will predict the mask. And there's one more task called next sentence prediction. So we train with jointly with 2 sentences. And like BERT has improved, like in English itself, it has improved like around 5% improvement on all the NLP tasks. So currently we are working on it. Even though the code is open source by Google, the tokenizer is not compatible with our Indic languages. Currently we are working on like in the tokenizer part. As far as we finish, we will also open source it. So all the models and codes are open sourced. So you can check it out IndicNLP.org. So Adam will talk about more about our platform.
So whatever we have done, we put it on our GitHub, and we found a lot of people interested in the project. And we wanted to bring everyone together. That's when we launched the website called IndicNLP.org. So we put all the information that about the project, what we have done so far, whatever tools that we have, all the GitHub projects in this website. So there is no data tagging platform for Indian languages. Maybe not for any language that is publicly available. So we wanted to do a translation task. That's when I built a small Django app and for translation. But I know it didn't work that well. But that's when we found a project called Docano that is recently released. In that project, right now we have added a dataset for named entity recognition. So we can select. So what I'm selecting is Bangladesh. It's a location. Tajuddin Muhammad, it's the name of the person. So this is a news article, and we are tagging it for named entity recognition. Similarly, in Tamil, we have the dataset uploaded, and we have just started tagging. So we are coming to the big question: how can you guys help us? I mean, how can we do this as a, as a project together, right? So if you know how to tag data, you can just come to our platform and help tag data. So if you know Tamil or Malayalam or any other language, Indian language, we can help you add, work with us and improve this IndicNLP into all Indian languages. So, and if you know English and Indian languages, we can use it for translation. We don't have any translation data set for Indian languages publicly available. Similarly, if you are a linguist, you can help us, frame good tasks which is different from English. There will be different tasks in Malayalam or Tamil which we don't know yet. How the language NLP models improves is that we actually create a data set and people try to create the state of art models on top of that. So if we can actually create a good data set in Indian languages, then all of different people will be competing to create the best state of the art models. So we'll actually have a good code and data sets publicly available. That's what we are aiming for right now. So these are some of the other contributors that has helped us in building the UI, in building the the websites and everything, and even the crawlers. So we have written some of the crawlers that goes to Indian websites and crawl and get us news data and everything. You can also contribute to that.
Meet again. So can you talk about your volunteer community, especially the non-technical people?
So currently so after coming here, I spoke to a lot of people, and we have started a Telegram group. So you can join the Telegram group. I'll be providing the link to the Telegram group in the website. You can come there, and there is a Google developers group. You can sign up in that. So you will be getting all the emails about all the different languages. There's also a Facebook group. You can be a part of that. So I would suggest join the Google group, because you will be you'll be getting emails, and you can, if you're working on anything, you can also share it with everyone.
Yeah, our gang will also join.
Sure.
Okay.
Hello. So actually, I'm asking, what kind of tokenization method did you use?
So
Or Malayalam or Bangla?
Yeah, so currently we are tokenizing only using the space and punctuations. So that's actually not correct. So, but the model used to learn it anyway. So currently we are only also working on like byte pair based encoding. That's a word piece vocabulary based tokenization.
So actually, you
Mm.
can use byte pair with English, but I was like, I'm also working on same thing. So
Mm.
how can we use byte pair for Hindi or any other Indian languages? If you can share something.
Yeah, there's already a library by Google, Sentence Piece, if you know, I don't know.
I know it.
So you could train like with the large corpus. We already created the word piece vocabulary for Malayalam for like bird training.
Okay,
So
I'll
I
check
will
it
share
out
the
then.
codes with you.
Okay, okay. Thank you.
So I wanted. So most of the approaches that you mentioned, the processes come when it comes to crawling or training a word-to-vec model, which is unsupervised. All of this can be applied to any language. So what did you have to do specific to Indian languages, or how is training NLP models for Indian languages different from training it from any other language or say English? Because most of the stuff that I found in your talk
Yeah.
was generic.
The technically we didn't do anything different. One thing we are trying is to create a tokenizer. That's the one problem we face right now. But this is like the very few of the attempts to create language modeling and release the model data also in public.
Are there any challenges that you faced with Indian languages that weren't with English?
One primary thing is tokenization, because even with the byte pair encoding, the Unicode representation of our Indic languages is a little different. The single glyph, I'm not sure whether if you are from Tamil, ik means ka plus there is a dot in the top. Those are different Unicode points. This creates a problem when you use byte pair encoding. We are working on solving that. We are seeking help from people who have knowledge in linguistics, who understands language and the grammatical structure, because we are not linguistic savvy people. So that's one challenge we face. Other thing is a lack of data sets, because we just crawl the newspapers. That's easy to do, but creating name entity recognition or past data sets, for example, name entity recognition, anyone can tag the data. Okay, you understand what's name and what's place, but when it comes to past tagging, part of speech, whether it is a noun or a verb or something, complex than noun and verb, which I don't know, that is not easy for common people to do that, right? So we need linguistically savvy people to help with annotation.
Do you have anything on transliteration? English, people like Tamil in English or Hindi in English. That's what people do when they don't get a keyboard or whatever reason.
There is one project for Tamil, Open Tamil. I think they have a transliteration package. I'm not sure for Malayalam.
Even for Malayalam, there is a publicly available transliteration tool. So we are actually thinking about using, like, applying deep learning on top of transliterated text, because applying BERT and all these libraries on top of transliterated text will be easier. So we haven't tried that approach. We are actually looking forward to that.
No, lot of data set is actually available. Like if you do any name entity recognition, a lot of data is available in English. If you can transliterate into language, it becomes easier some way. Okay. Another part, lot of early content. Even in government, they don't use Unicode much. It's in Tamil, it's in Anjal, or if you use railways, they are not using Unicode for now. That's what I understand from. So older content, if you can have Murasa Anjal, a lot of other format, Tamil 90, and we had a lot of standards earlier. Because I did something about 20 years back, so I'm looking at what you can come with that part. Yeah.
One thing I want to mention is you mentioned about translating data sets, right? So there is a squad data set is a question answering data set. You are given a passage and some questions. You are supposed to answer those questions within this context of the package. When we tried translating, most of the sentences were gibberish. For example, to give an example, Nilavil Party Vadai Suttu. This is a Tamil phrase which means there is a lady in the moon who is cooking up vadai. But the translation we got was there is an old lady burning in the moon. So it is a little hard to just trust the translation. Maybe that was from Google translation. I think cockroach in Malayalam was a little different. I don't think we can say that in public. So, yeah. Any other questions?
Hello, yeah. So I had a slightly different question. Like you said about tokenizers and all, can we apply the techniques that you're using for things like applying CTC loss on text that you're trying to do? For example, if I'm trying to do handwriting recognition, but I want to run an NLP task on what I get from it, so like a CTC loss to fix it, or word grams to try and predict missed or sentences. Can you talk a little bit about those kind of applications in Indic languages?
If I understand correctly, you are also applying OCR, right?
Yeah.
From OCR. I do not have personal experience with OCR, but we trained speech to text model. That
Okay.
also uses CTC, but I still do not understand completely to answer your question how CTC works. I'm sorry.
What about skip grams or n-grams?
I'm not sure. Can you
Ingrams on.
What exactly is question?
So if I'm trying to classify, if I'm missing a word in the middle, trying to predict that word based on the previous words and the words after that.
Yeah, you could actually use Skipgram or any language model.
So have they worked properly with with Indic languages in your experience, or have you faced any problems? That's my question.
So you could actually try our ULM fit model, which is just the state of art now. This is around 36% perplexity. We tried to generate samples using that language model. It was actually pretty good. Grammatically, it's correct. So it was like we generated from it scratch. So we didn't actually try just filling out some words. So actually, I can't assure you.
Okay, thank you.